today we will dive into week 5 of model monitoring homework. So let's get into it. So the goal of this homework is we want to monitor the right prediction model that we deployed a few weeks ago. And we will be using taxi data for this task. Before we start this homework, we want to set a few things and make sure that the data is available for the task. So we have already provided two models. One model is trained on March 2021 data, and the other model is trained on the combination of 2 months, which is March and April 2021. So you'll be asking why that's the case, and the purpose is that we want to compare that once we start predicting on unseen data, which will be in May 2021, we want to see whether the model which it was trained on March 2021 has that model, the features for that model has those drifted. And similarly, if we train the model on 2 months of data, and when we compare with the unseen data, like has the new features or the new data which is coming in, has that drifted from the original data? So that's just the goal. And so we'll take step by step. So for this homework, we have already done the heavy lifting for you. What that means is that we have provided you with both the models. One is this one with no version attached and the other one with a V2 attached, right? So the V2 is the one which is trained with 2 data sets, and V1 is the one or with no version is trained on this, okay? The other thing to notice is the Docker Compose file. We're, as an environment variable, we're providing a model file over here and giving it a model version 1. And if you look at the Docker file, we've already attached both the models, and we added both the models to the file. So how does the prediction service knows which one to use? The logic for that is in the app.py file, and we are using this logged model, a constant. So we look at the environment variable model file, which will be coming from the Docker Compose, and if not, then use this one by default, okay? So we can just use the environment variables to control which model to use. Okay, that's the high level logic and the workflow. Okay, so let's go back to the homework. So we wanted to make sure that we do some preparation and data is available. And the preparation says we need to download data for all the 3 months. For that, we will run prepare.py file. Okay, so let's do that. However, we want to make sure that to run these scripts, our environment is set up. So let's set that up first. For that, we can use conda and create conda environment. Conda things create. Then we just specify the name, the -n, we can call it MLOps monitoring, and let's give it a Python version. And so Python version is 3.8 for this one. Give that a go. And it's asking us whether we want some new packages attached or the prerequisites. Just say yes. Let's continue. Once that's created, we conda tells us that how to activate this environment. So we can copy this command, paste it in our terminal, And now we have that activated. Okay. This does not mean that we can now run the scripts. We still need to install the libraries. For that, I have created a requirements.txt file. Few things to note here, that I've given a version greater than equal to 2.0b for prefect. Some people noticed issues if they get the latest version. Hence, I will hard code it to the stable version, which I know the homework works with. So just change that here. The other one I need is pip-end for the later part of the homework. So I'll just add that here. Okay. And then we'll quickly do installation. So before running that, I'll check whether my Python and pip is pointing to the correct virtual environment. For that, I can just do which Python, and it's telling me it's using the environment MLOps monitoring. To do this in Windows, I think you will use where clause instead of which. I'll also check my pip, and yeah, it's pointing the right virtual environment. So pip install, let's do -r, and then requirements of txt file. This will take a couple of minutes. I'll pause it for that time. Great, everything is installed. I did not need a lot of some of these libraries, such as I think Prometheus client, maybe one or two couple more. I think I just copied it from week 5 learnings, and yeah, just ignore them, but it should work. Okay, that's the main goal. So let's go back to the homework, and we just want to run the prepare.py script. So just quickly looking at that, for that we need a datasets folder, and we have 3 files which we will be downloading. Okay, so just go here, file, and just go make dir datasets. Once that's created, then we just run Python prepare. I'll pause it until the datasets get downloaded. Great. Now datasets have downloaded. For that, we can just click in this datasets folder, and we can see that 3 datasets are available for us. So we can keep going forward. So what does it say? So we have prepared that, and it's also saying for question 6 and 7, we want to prepare the dataset which combines 0, 3, and 4. And for that, we want to run prepare reference dataset file. Okay, so this dataset file is in prefect monitoring folder. Which is prepare reference data. So let's just run that. Python reference data. Should be a couple of seconds. I get the error that the file not found. I think the problem is because I'm running it from this folder, and then the file reference from that directory is not found. So I'll just quickly move to prefect monitoring folder and then run that. And that's working now. Moving on to the homework. Okay, so it just says the starter code is already prepared. So let's move on to question 1. So question 1 is saying we've already provided a Docker Compose file and we want to run the Docker services. So once they're up and running, we want to ping the local host for Mongo, so the Mongo server, and we want to know on pinging it, like what message it displays, whether it's in the browser or general. Okay, so let's do that. So I'm gonna cd out of this, and we're gonna do Docker Compose. So -f stands for file. So by default, if we do not specify this, it will look for docker compose.yaml file. But we don't have that and we have a homework. So like a suffix attached. So hence I'm just specifying this file location. Okay. Then similar command up and -d. Let's do that. So this will take few seconds. I'll pause the video until this gets completed. I'm saying seconds, or probably will take minutes. So now both the images were built, and the Docker Compose was able to build and network the services together. We can quickly see that if our services are up, do Docker PS, and we can see that both homework prediction service and homework Mongo 1 or Mongo essentially, they both are up. That's good news for us. Okay, so let's quickly ping the service. I don't think we'll get a message, but let's see if we ping directly from the terminal. Otherwise, I'll show you the browser message. Okay, so this does not work. I'm just giving unknown host, which is fine. So let's quickly copy this code and look in the browser. So I can see on typing that, the answer, it looks like you're trying to access MongoDB over HTTP. So that's the message we get. And that's the answer to the question. Okay. So the answer is this second option. Moving on, the next question is about the Docker volume. So we have set the Docker volume to record our MongoDB specific data. So any request which will come to the prediction service, it will basically produce the prediction, but at the same time, it will save it in the MongoDB. Okay, and the logic for that is very similar to the week 5 exercises. So we can look that up in the app.py file. So just over here, we have this save db command, and we save it in the Mongo collection, right? And we've already defined the configuration for the Mongo client, DB and collection here, and that gets used in the save DB function. So we just want to know what's invoking that function. So we've defined this prediction duration endpoint with a post request. So as soon somebody makes a request to this duration, or the application makes a request to this, this will come in. Our features our features get prepared, or the feature engineering is done, for example. Then model gets called and prediction is provided. And finally, we call the save DB function to save them in MongoDB. So all that data needs to be available to us. If we don't provide a volume and we just have a container, it will score it, but as soon the service or the Docker service will go down, all the data associated will get lost. Okay, hence we just decide to save it in the volume, so we can bring that up or bring it down, but the data will remain the volume. Okay, hence the Docker volume. So the question, however, is we want to know what is this volume so we can keep it safe and not delete it, and what's the command to find the name of the volume. Okay, so let's do that. We can do by docker -- help, and we can see there are a bunch of commands here. Let's scroll through them and see if we can find anything associated with volume. Not here. You can see volume here. So these commands are under management commands. Okay, that's great. So we can do docker volume -- help again. And then it tells us there are a few commands we can use. We can create a volume, we can inspect it, we can list, we can prune, which is removing, or rm. So looking at all these options, to me the one which makes sense is docker volume ls. So we can do that. And there we go. We can have two volumes. One is this local, and the other one is this homework Mongo data. So I think that's the one we're looking for, and that's available for us. Right, so that's the answer. The next part of the question is we are saying that the service is now up and running. We know when the request comes in, it makes a prediction and saves it to MongoDB, right? We just covered. Now, we want to run a script and score 5,000 random predictions with the first model. And then we want to know that when it makes the predictions on the last data point, what's the prediction? Okay, so what's the score the model gives it? So we can look into our prefect monitoring script. In this, we have send data, and we look at this. We look at our 2021 May data, and we sample 5,000, and we're using a specific seed, so everybody will get the same predictions. Okay, we score them with the service. So, and all these services will be all these predictions will be printed in our shell. So we can just pick the last one to answer this question. Not too complicated. And we know, okay, how do we know it's using the first model? Well, that's simple. We talked about it. You can see that the model file is pointing to the version 1 of the model, which we built. And in prediction service on top, we're just using that environment variable. Okay, so the log model and the model version 1. Okay, so let's go into the prefect monitoring directory and run send data. I've already prepared a pip file for this. The only issue is the prefect version is not correct here. So let's just quickly set this up as well before we proceed further. So we will do pipenv install and we'll just do it to version we know, which is stable. Okay. So I'll pause the video until all these requirements get built. Okay, seems like it's all ready for us to use. So we'll just do pipenv shell to get this activated. Great. Now let's run Python. Let's run the send data file with Python. This is the file we are running. We don't have any cache, that's why it's taking a few seconds to fire up. The second time we will run this, it'll be super fast. This will take a couple of seconds. And this finished. And we're interested in, according to the homework, we're interested in what is the last prediction for this current model, okay? So hence the answer to that is 15.74. So it's option B, okay? The next part, we want to generate the evidently report using prefect. We've already prepared that script. The only thing is that we have left two functions blank here. One is save report and save HTML report. So this one is similar to week 5 exercises, which we went in the monitoring videos. And in this report, we are just saving this report to MongoDB. And the HTML, we just generate the HTML report. Okay. So let's quickly do that. We can see we're getting all these yellow squiggly lines because it does not know that which Python we are using interpreter. So we can change that. Select interpreter. I cannot see the one for it now. So we can just do pip in. I forgot the command for it. Maybe --when. It will tell me. Okay, yeah, that was it. So copy this. Go back. Select interpreter. And then I'll just enter the path. Oh, that resolved it. And I also think all our imports are all over the place. So I'll just see if I can sort these. Yeah, now it's a little bit better. Okay, moving on. So the tasks here in line 94, we are able to generate profile and dashboard. Now we want to save the profile and we want to generate the HTML report. Okay, so let's do function by function. So first here, in order to save it behind Mongo, we need to call the Mongo client. So we initialize that. So we've already defined Mongo client address. Then we need database and the collection. So I'll just copy these below our reference. The next is we just want the report collection. We're not interested in prediction. Hence, let's go. Collection is equal to client get database, and then we can just save in Mongo database. Then we can do .get collection, and we're interested in report collection. Okay, so this will create an empty collection for us, or in traditional database, more like an empty table for us. Okay, or basically this is an object, right? We initialize an empty object. So all we want to do is now save this, save the result, which is the profile, to this collection. So for that, we do collection dot insert one. Okay. So this completes our function. You can just add a dot string or a dot string. Right, so that's it. The next is generating the HTML report. So this is quite simple. You can just do result dot save, write prediction, drift report dot html. Right, super simple. Now, what happens if we want to run this script again and again? The only problem I see, it will overwrite this. So a good idea could be if we could version control this. So how can we do that? Maybe one way is using datetime, or the other one is, just environment variables. For simplicity, let's just do datetime. And we can add a parameter, more like file name suffix. And what we can do here is then we can call datetime object. So we can just save it like this. If you want to further format it, and let's say I don't think we will run it more than or every minute. So we just format it to that string. So this is year, month, day, hour, and minute. Okay. And then for the final saving result, we can do something like f-string formatting underscore that's it. Again, we can just add a quick doc string function to generate write prediction HTML. Something like this. Okay, not too complicated. Okay. Now let's quickly run this. Again, this will take a minute or two. Since I don't have cache, I'll pause it. The prefect is running, and on my left side, I can see it has prepared this HTML report. and I would like to see this report, right? To know how many features have drifted. So the homework said how many model features have drifted based on the HTML report. Okay, so I right click and I can reveal this in Finder and then open it in the browser. So here I can see that 3 features, according to the evidently report, have drifted: our target variable and the location IDs. Now, this question, I would say, I think I would let you, maybe the way I want to put it, that in machine learning, usually model features are the features we use to make a prediction, right? So according to that, only 2 features have drifted. But in the evidently report, it's looking at even target as a feature here. And that's something, a terminology more specifically to evidently AI. So even if you answer 3, the answer is fine. Even if you answer 2, answer is fine. But what I was trying to ask, how many model features have drifted, okay? And the accurate answer would be 2. Let's move on. So next question is, what's the name of the test? So what's the stats test for location IDs? So we can quickly go back into our evidently report, and we can see for location IDs, it's Jensen-Shannon distance. Okay, that's the stats test which has been performed to detect whether this feature has drifted from the original data or from the training data or not. Okay. Going back to question 6. So now what we have to do is, now we know some of the features have drifted. We want to now run we now want to make predictions using the new model, right? And we want to simulate what we did for question 3. So we will send data to the service and score it. And then we will find out that based on the newer model, which was trained on 2 data sets, what's the prediction for the final data point? Okay, so let's do that. The few things we need to just check. So it's saying that once we update, so what we need to change is we need to change the environment variables in the Docker Compose file, the model file, and the model version. And once we updated it, we have to restart the servers. So by servers, I mean we have to restart the Docker Compose service. Okay. So let's quickly do that. So we will change this to version 2. And according to prediction service, we have v2 file here. So I'll just change that to v2. Awesome. I'll also want to clean my Mongo client, my Mongo server, because in the next question we will be reusing some data to check the distribution, and I don't want to keep generating data there, and I think it gives odd results. Hence, I prefer to clean the Mongo service. So let's do that. So we can do that by running Python clean Mongo. So this file, we just clean the database. So now that's done, we will restart the service. Go one directory down, do -f, sorry, now one directory down, docker compose, and then down command. Then we can bring this back up again. Great. So we will send data again according to, that's what the question 6 is asking, that we will simulate the traffic at the same data points running send data file. So let's do that. And this time it will be quicker because we already have the cache of running this file. We'll give it a minute. Pause it. The model has scored the new predictions, and we just want to know with the new model, what's the last prediction made, okay? So it's not, you can see it's 16.6439, so that's the duration, so we'll just choose that option here. Okay, the next step is generate the evidently report with the new model. We just have to make a few changes. The changes are that in our evidently file, sorry, not in our evidently file, in our prefect monitoring file, on top, we're using the old model, and we should be changing that to the new model. So that's one change. The other thing is we have to change is, I think I lost the homework file. The other thing it's saying is we have to change the data set. So in the beginning, we had to prepare a reference data set, which is a combination of 03 and 04 2021. If you forgot to do that, just go back to, just within the directory, run python prepare reference data. So just run that file, and then you should have this data set available for you. So we'll just copy this and prefect monitoring script. We'll just change this here. So this is changed. Now we're using the latest version of model. The other way to do it is you can just have the environment variables. You can do an export command in the terminal for your reference data file and your model file, and you will pick up the latest model rather than changing in the code. Okay, I'll leave that up to you. So let's run the prefect monitoring again. And why are we running this? Because the homework is asking us that so we run this script and we want to know that has any other feature has recorded drift, which when we ran in step 3 with the older model, the same feature did not record any drift. So do we see any changes that any new feature recorded drift with the newer model? Okay, so that's what we're trying to check, and which one that is. So let's run that. So now evidently has produced a new report for us. according to my time. Let me check which one. So this one is 1954 on top, and this one is 2005. So I think this is the latest one. So I will reveal this in Finder and then open this. So according to the old one, you can see the trip distance. There was no drift detected, right? But the new one, with this 2005 report, the trip distance detected drift. Okay, so that's the answer to our question, because in the previous step that did not record any drift, but in the new one it did. Okay. Question 7. So the answer is trip distance to this question. Correct. Now the final is a bonus question, and it's only up to you if you want to do it, but I think it's super useful. So we generated a profile, and then that profile was saved in Mongo. So we just want to extract it and see that what's the number of metrics or length of the metrics for that collection report. Okay. So how we can do that? We've already provided a startup script for it. That's monitor profile notebook. So let's just run that. And we need to connect to the Mongo client, right? So let's just type the code. What's the address? I don't remember. And then the collection equal to client dot get database, and then dot get collection, and then we'll pass in the collection name. So we can just get those from prefect monitoring. Quickly copy those. Code file here. And we are not interested in prediction collection, so we'll remove it. And here, so let's run this cell. Call the Mongo client. Mongo database, and then report collection. Now that's our collection. Now we want to print this and see if we can get the metrics out from this profile. Okay, so for that, we can just go into, we can be like, okay, how, I know how to do it, but if you forget in the future, you should also know where to go and find this code. So I'll quickly show you in the browser. So we can look up PyMongo documentation. Let's click on tutorial. I'll go one step back. So I started here, and then on top there was tutorial. I clicked on tutorial, and it has how to connect to Mongo client, getting the database, getting the collection, the documents, how to insert a document or a collection, and how to get a single document with using find one if we already know the object ID, for example. And we can also do bulk inserts, like insert many, and we can also go more than one. Okay, so this is what we're interested in. We want to find all the reports. We only published one, so I think if we do .find method, we should be able to get everything associated. Okay, so I can just copy this and we'll change post to call because I just want to keep that. And we called our document as collection, and then we just print, call, which is our collection. So running that, you can see you can get the data associated. We have an identifier, data drift, and we're interested in this metrics. Okay, so you have a data drift and it's nested dictionary. So then there is data, and behind data there's metrics. Okay, so let's extract the next nested dictionary. The next is data drift. Then behind that is data, and then there is metrics. So now we're getting the metrics. So we're interested in the length of the metrics. So we have these keys associated with each metric. So in dictionary, we can use dot keys method to get all the keys associated. I print that, and we can see we get all the keys. We can manually count them: 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And if we just want a friendly way to display it, then we just pass the length argument, len. It's a Python way of checking the length of an object, then just running that again. So that gives the answer 9. So that's the answer to the question. One thing I want to touch upon that this profile could be very useful. So for example, we looked up all the keys, right? And one key here which I'm interested in is end-drifted features. Okay, so let's look at what does that contain. So this is telling me that 4 features have drifted. Yes. So I could have some kind of an automation where if number of features are drifted more than X or a percentage, then I would like to retrain my model, okay, with the new data, for example. So I could check that. So something like, you can run this in the next command as well. And we can check and features. I think that was another key. And we can see 5. So the end drifted features is 4 out of 5, and we can have some kind of a rule if drift is more than 60%. So we can have this divided by this here, then do some kind of model retraining, so we can automate that. Yeah, so I will end this video here. Thank you so much for staying with me. Really appreciate it. Hope you enjoyed week 5 learnings and the homework for week 5. Cheers. Thank you. Bye bye.